Hi guys, so today we are starting a new topic, the new unit, which is called polynomials and factoring, and I'm going to go over this material. So we're going to go over this worksheet and the back of it. I posted it all online on Google Classroom, but I do think that most of you have the paper copies of that as well. So to get the 100 on this assignment, you would have to have your name on the worksheet right here. If you don't have your name, I'll take the points off. You have to have all the notes that I mentioned in this video. So everything has to be written down. And then also you have to show the work for everything. So you have to do what I do. I'm going to go over the notes. I'm going to go over all the examples on this side. And then I'm going to go over only odd problems on the other side. And then you're responsible to do the even ones. And again, you have to show the work. No work, no 100. Okay? So let's start. First, we're gonna find out what the polynomial is. Polynomial is an expression that consisting of many terms. So polynomial. Poly means many. Nomial means terms. So it's many terms. So it's an expression consisting of many terms. And now we will be talking about standard form of polynomial. Standard form of polynomial. But before that, I'm going to, of course, give you examples of the polynomials. Okay, examples. So 4x squared minus 1 would be polynomial. A plus b would be polynomial. 9x to the third plus 7y plus 75 plus 2x is a polynomial. Okay, now I'm going to let you know what standard form is. Standard form of polynomial is a form when the variables are written in alphabetical order with the highest exponent first. And the powers of the exponents have to be in the descending order. Powers of exponents are in descending order. Descending order. Okay? So, examples that they've given you these are the examples, okay? So what do we see here? Problem number 1. We see, how many terms we see? 1, 2, and 3 terms. They're all, the terms, by the way, of the polynomial can be separated either by addition or subtraction. So we do have the addition here. So 1, 2, 3 terms that we're dealing with. Well, are the powers in descending order. I see x to the first power. I see no x here, but it's actually x to the 0 power because anything to the 0 power is 1. And then x to the second power. So second power is the highest power here. So we have to put it first. So 2x squared goes first, then 3x follows, and then 1 follows. Okay, so second degree, first degree, and no degree. Like there's no x. All right, problem number 3. We're dealing with w as our variable, right? So we do see that it's w to the third power to the second power. There is no w and there is w to the first power. So we have to change the order a little bit so that we are dealing with standard form now. So it's w to the third power. Then we have to look for the term with the second power. So 5w to the second power minus w. Please pay attention. W is right here. Negative, this minus is attached to w. So when you bring it after the 5w squared, you have to bring it together with its sign. You cannot just leave positive and then put that w. Positive plus belongs to 28. So, and then it's going to be our last term. All right, problem number 2, I kind of skipped. So we're dealing with k to the k a variable. Okay, take k to the second power. There's no k here. K to the first power and k to the third power. So the highest power is k to the third power. And we see there's 7 up front and it's positive 7. So that's what we're going to put 7k to the third power first. Then we're looking for then we have to mention them in descending order. So 2 goes after 3. So k squared is going to be next. Y plus because k was positive. There was no negative sign in front of it. So now regular k is following and just k to the first power is following. And then we're adding 64 because it doesn't have any variable. So it's actually 64k to the power 0, but we're not going to talk about that too much right now. Okay, number 4, we're dealing with our n variable. We see that third is the highest power. 3 is the highest power of n. We do see that negative is attached to this n here. So that's what we're going to put in front of n to the third power. Plus n and plus 24. So what we have, n to the third power, then there is nothing with n to the second power. So we're not going to make anything up. So there's nothing. So there's nothing. So so then the next term would be n to the first power. We don't put 1 because it's, that's what it is. And we don't write that down. So plus 24. 24 was positive. Problem number 5. Here we're dealing with A and B. Again, the terms have to be written in alphabetical order. So A is our main variable. So here we see that. So that's what we have to start with. A. Do we have any just a term? Yes, we do. It's a to the third power. A to the third power. Now, do we have anything else with a? We do have this and this. So a here and a here. A to the second power is here. So it's the higher power than 1. So this term is going to come next for this reason. Then the next one, what is left with a plus 2ab. And then the last thing, what we're going to write down is what's left. Number 6. We're dealing with C and D. C comes before D in the alphabet. The highest power of C is 3. And this is this term. And it's going to go first. Then this term has C in it also. So we're going to copy that. And then we have D variable. It goes next. And then just the number goes last. Okay, so it's 13 times variable to the 0 power. All right, now we'll be talking about the degree. So as I already mentioned, we're talking about different degrees, right? Our variables have different degrees in polynomials. So depending on the degree, there are different names for our polynomials. So if the polynomial is of degree 0, the polynomial is called constant. So I'll give you an example. For example, number 6 is constant, and this is also a polynomial. Actually, it's a monomial. It's a little bit confusing on these worksheets and my key, why they saying that constant is a polynomial. To me, it's a monomial because it has just one term. Mono means one. But let's just let it go. If then first degree polynomial is linear. For example, x plus 5. X is to the first power. There's no x squared or anything like that. So then next one is quadratic. For example, x squared plus 2x would be quadratic because the highest power is 2. The third degree is called cubic, when something is cubed. X to the third power plus 2x plus 7. The highest power is 3, so this polynomial is cubic. The fourth degree polynomial is called quartic. X to the fourth plus 7x to the third plus 2x squared plus x would be an example of that. Okay, now let's talk about number of terms. The polynomials have different names, and it's based on their number of terms as well. So when there is one term, it's called monomial, like I was saying before. So it's a contradiction here because it says that polynomial is an expression consisting of many terms, and monomial is actually consisting of one term. So that's what I was talking about a little bit before this. So this a little bit doesn't make any sense, but again, let's let it go. But this is like a little bit of a red flag for me, so it should be for you as well. So when there is like monomial, one term, x or 2x is one term. 2 and x are glued together by multiplication, so it's actually 2 times x. So if it's multiplication between the two number, like a number and a letter, it means that it's still one term. If it was plus, 2 plus x, it wouldn't be a monomial. It would be 2 terms. 2 is one term and then x is the other term. It would be binomial. X plus 2 is a binomial. So x is one term, 2 is the second term. Trinomial. 2x squared plus x plus 7. So 3 terms. 1, 2, 3. And then polynomial, even though trinomial is also polynomial. So it's contradiction right there. But polynomial is 4 or more terms. For example, 2x to the 7th plus 7x to the 4th plus 3x squared plus x plus 5. This would be a polynomial. It has, in this case, it has 1, 2, 3, 4, 5 terms. Now, number 7. I'm going to go over the examples. So we have to classify each polynomial by degree and number of terms. Okay? So by degree and number of terms. Number 6. The degree of this is 0 because there is no variable. So it is constant. And then it's also monomial, because it consists of one term. This term, 6. Here we have a variable, and variable has first power, so it's p to the first power. Once we're dealing with the first power variable, we're talking about a linear polynomial. So it's a linear, and then let's count how many terms. 1, 2. So binomial. Again, 7 and p 7p is one term. It's not like one term is 7, the other one is p. They're glued together by multiplication. If we're dealing with multiplication, it's one term. So there's one term and two terms. Two terms binomial. Here's the same thing. 4 times a to the third power, it's one term, and 8 is the other term. So here, we're dealing with binomial. Binomial. And the highest degree of a variable is 3. So we're dealing with cubic polynomial. Here, the degree of x is 1, so we're dealing with linear. How many terms? Just one term, because -2 is glued to x by multiplication. So it's linear. So it's monomial. Number 10. How many terms do we see? 1, 2, 3. So this is trinomial. What is the highest degree of a variable? It's 2. So if it's 2, then we're dealing with quadratic polynomial. Quadratic. So it's quadratic trinomial. So here, how many terms? 1, 2, 3, 4 terms. So if there's 4 or more terms, it's called polynomial. What is the highest degree? The highest degree is 4. So we're dealing with quartic polynomial. Okay. So I think I'll stop this video for now, and then I'm going to do the other page in the other video because it takes a long time for me to upload everything.